The graph of the tangent function is considerably different from the sine and the cosine graphs. It is not a continuous function like those functions are. We still see it being periodic though, which makes sense because we're used to the unit circle and we know that we can rotate infinitely many times around the unit circle. Where tangent has distinct differences comes from the fact that the tangent function is a quotient function, and that means it is created from the quotient of sine over cosine. We have seen when we evaluate tangent that there are times when it can be undefined, and that is when the denominator is 0, when cosine is equal to 0. And where that happens, if we think about our unit circle, happens at these 2 points on the unit circle, at pi over 2 and 3 pi over 2, otherwise known as negative pi over 2. And when we studied tangent inverses, or the inverse tangent function, we didn't know what the graph looked like, but we knew that the range of the inverse tangent was in this pair of quadrants, but it did not include these 2 points because of the discontinuity. What you have in front of you are basically an XY table of X values and tangent values at those X values. So here you can see your undefined points at negative pi over 2 and pi over 2. You can also see those sort of famous ones where tangent is 1 and negative 1. Those are also things we're used to seeing. And so what happens here is that the tangent value actually increases. And when they say without bound, that means it doesn't ever top out. It'll approach infinity. As x approaches pi over 2 from the left, and it decreases without bound, that means it'll keep getting smaller and smaller as x approaches negative pi over 2 from the right. And if we were to take this xy table and graph it, this is what we would see. We would see these little places in the tangent graph where we have discontinuities, and those are at the pi over 2 points, right there. So if we look at these little pink dashed lines, these are actually the vertical asymptotes. And that's why we learn about that in Algebra 2. It does happen in other functions besides rational functions. And in the sense that tangent has a denominator and a numerator, it is considered, I guess, kind of a rational function simply because the denominator can be 0. And that's where these vertical asymptotes come from. So here we have some really nice information about tangent. Notice this particular piece of information, the period. Notice that the period is not 2 pi, even though the unit circle moves in a 2 pi rotation. The tangent graph gets interrupted by asymptotes at pi over 2 and negative pi over 2. So really the tangent graph can only move continuously halfway around without being interrupted by an undefined value. The range here, if you check this part out and you look at one, I'm going to highlight one of these tangent curves, just one piece of it right here. You notice that it's going to keep going on and on forever, and it will get very close to those asymptotes, but never actually cross those. Those lines, those pink dotted lines being asymptotes, are not actually a part of the graph. They're just signifying that the function is approaching that value but never attaining that value. It is symmetric with respect to the origin, and it lists out the domain and range here for you. So here they're talking a little bit more about the vertical asymptotes, talking about the domain, and now we're talking about sketching. And this part is actually probably the most important thing on this slide. We've already kind of talked about the stuff at the top. It's similar to sketching the others in the sense that you locate key points and identify the intercepts and identify the asymptotes. The tangent can still have what we call a phase shift, but it doesn't have a vertical translation because the graph of tangent is already traveling more or less in the vertical direction. So it's not going to really shift up so much as it will phase shift left and right. Let me draw in a little arrow there, left and right. So what we do here to find where the asymptotes are going to be, we take the stuff, and I like to say stuff, but we take the quantity inside the parentheses, and we set them equal to the original parent function's asymptotes. So negative pi over 2 and positive pi over 2. And by solving for x, I'm going to write that here, solve for x in both situations, we will get the intercepts of the asymptotes. It says here that the period of the function is the distance between the two consecutive vertical asymptotes. So that's important to recognize. Now, as far as amplitude goes, we don't really define it as an amplitude because it's not something like the sine function where it has a min and a max. The tangent function is going to keep getting bigger and bigger in this direction and keep getting smaller and smaller in this direction. So there really isn't a min or a max here. So we can't really define an amplitude. But the outside A multiplier represents a vertical shift, really more of a vertical stretch in one direction or another. Here you have an example where what we would consider the A, or the amplitude, or the stretch is 1. So this really isn't going to play into it much, but what we really have here is we have a B of 1/2. So if we take this stuff, this is really the expression inside the parentheses, and we do what we saw a couple of screens prior and set that quantity equal to over 2 and positive pi over 2. That is where our new asymptotes will occur. Now we can plot a few points. What they've done here is they've plotted, we know this is the asymptote, and this is the asymptote. So what they did was they plotted basically midway in between, and then they subdivided again, and they got some y values. And then they plotted those points, like so. And so what you see here, this is different from the parent function. The parent function actually has the asymptote at negative pi over 2 and positive pi over 2. So you can see how that 1/2, that B being 1/2, let me make a little asymptote. This is the parent, tan x. You can see how the change here, the 1/2, has changed the asymptote location. The graph is still essentially the same. We don't have a lot of different behavior going on, and tangent won't vary that much. But this is what it looks like when you have a change in the frequency.